I want to show you how to apply the first law for an open system to a steady state, steady flow device, an adiabatic turbine. In this example, steam flows through an adiabatic turbine at 10 megapascal, 450 degrees C, in 80 meter per second. It exits the turbine at 10 kilopascal, 92% quality, and 50 meter per second. The mass flow rate is 12 kilogram per second. We want to determine the change in kinetic energy, power output, and inlet area of the turbine. The same four-step process to solve any problem. Identify the system, process, substance, fill in the table, determine work, and apply the corresponding first law. As we discussed in class, in this case, since the turbine is adiabatic, Q dot is equal to 0. The system is an open system. Turbine is a steady state, steady flow device with a single inlet and outlet. Here is the general conservation of mass equation, where the summation of mass flow rate must equal to all of the mass flow rate out of a steady state, steady flow device. The mass flow rate is defined as the equation shown, velocity times area divided by specific volume. The first law for an open system is defined as the equation shown here for a steady state, steady flow device. A couple of important notes. If the device is adiabatic, the heat transfer rate is equal to 0. In most of the cases, for a turbine, we can neglect the changes in the kinetic and potential energies, and the enthalpy is defined as U plus PV. We're now trying to fill the table. Since the turbine has a single inlet and a single outlet, we can drop the summation sign for the conservation of mass equation. Thus, the mass at the inlet and the mass of the outlet will be the same at 12 kilogram per second. Next, we use the intensive property given to find everything else we need on the table. At this point, I think we have done enough practices that you don't have to fill all of the blank properties, only the relevant ones. The relevant ones are mostly the properties that will be used in the first law later. At this point, we can also find the area of the inlet as well, which is one of the unknowns that problem is asking for. The mass flow rate is defined as the velocity times area divided by specific volume. From the table, since we know velocity and specific volume, we can plug them in and find the area, which is equal to 0.00447 meters square. From the given velocities, we can also determine the change to the kinetic energy. Since the unit we want is kilojoule per kilogram, the change of kinetic energy is defined as the velocity difference, velocity square first, then the difference, and then divided by 2. To convert its final unit to kilojoule per kilogram, we need to divide by 1,000 since its original unit is in joules per kilogram. and the answer turns out to be negative 1.95 kilojoule per kilogram. We are ready now to apply the first law. We are neglecting the change of the potential energy. Q dot is equal to 0 since the turbine is adiabatic. We then substituting in the mass flow rate, values of inlet and outlet enthalpies, and the change of kinetic energy. We then get that the power output is equal to 10.2 megawatt.